Okay, you ready for our medians? I again have my acute, obtuse, and right triangle. We'll do the acute one first. Our medians are the segment that's drawn from the midpoint to the opposite vertex. So we're not going to fold this like we would for a perpendicular bisector. We're just going to pinch it and get the midpoint of each side. So this is similar to what we did when we made our mid segments. We're going to fold each triangle in half from vertex to vertex, and we're going to mark where the midpoint is. Now, in order to draw the median, you need to match up the midpoint and the opposite vertex. This here is the median of this triangle. Midpoint to opposite vertex. This here is the median of this triangle. All right, here comes the last one, and you are not surprised at all that this median goes right through that point of intersection. This point of intersection we know of as the centroid of the triangle. Now, the interesting thing about the centroid is that it's going to divide each median into thirds. So if you think about it, 1/3, 1/3, and 1/3. So the centroid is 2/3 from the opposite vertex and 1/3 from the opposite side. An interesting thing about this centroid is it is also the perfect balance point of the triangle. So if you put your finger on that centroid, you can see that the triangle will perfectly balance. And we'll do more of this in class, but this triangle will perfectly balance on my finger because it's the perfect balance point. So the acute triangle, the centroid is in the center. Let's see about the right triangle. So we're going to fold each side of the triangle and get our midpoint. Fold each side of the triangle and get our midpoint. Fold each side of the triangle and get our midpoint. Then you're going to draw the midpoint to the opposite vertex. You're going to draw a segment from the midpoint to the opposite vertex, a segment from the midpoint to the opposite vertex. And holy cow, wow, there it is again. This is going to be our centroid. And again, it's 1/3 the distance from the side, 2/3 of the distance from the opposite. 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. Let's see what happens with the obtuse triangle. We'll again fold, mark the midpoint, fold, mark the midpoint, fold, mark the midpoint, and we're going to draw from the midpoint to the opposite vertex, midpoint to the opposite vertex, and our midpoint. I just love it when it happens. First of all, if it lines up, that means you're a pretty good folder. Because here we go again. Those three lines intersect perfectly. And of course, we know that this is the centroid. And it is a 1/3, 2/3 relationship. From the side to the centroid is 1/3 of the distance. And then here we have 2/3 of the sides. All ended up inside the middle of the triangle.